In my previous video, we talked about SPAN or port mirroring, which is, okay, you have a switch, you want to mirror a local port. Then you run some monitoring software to track the network packets. In this video, we are talking about another scenario, which is RSPAN or remote port mirroring. I will skip all the details about SPAN. If you are interested, please do check my previous video. If you want to configure remote port mirroring, you need at least 2 switches. Of course, they need to be linked together, and you may also have your uplink to a router. So in my case, I'm going to use 2 UniFi switches. There are no special reasons why I use these 2. It's just they are available and they both support the CLI which I need in this video. I'm going to connect 2 machines, one to run Wireshark, the monitoring station. The other one is just a regular computer. To configure RSPAN is much more complicated than the local switch port mirroring or SPAN. RSPAN configuration is to mirror or span the traffic to a VLAN instead of a local port. In order to copy the monitored packets to a VLAN, the hardware need to be able to do that. But unfortunately, some hardwares are missing that ability. That's why different vendors use different approaches to achieve RSPAN. For example, Cisco or Ubiquiti, they both require a so-called reflector port. The system will need a separate port, reflector port. It needs to be somehow connected, and then you define a RSPAN VLAN. The system can copy the monitored packets using that reflector port to your remote switch. The way Cisco and Ubiquiti implement RSPAN is a little bit different. In Ubiquiti's way, it's a little bit strange. Now I'm showing you the same connection diagram but with much more information. I list all the participating ports and some details. Let's go through this diagram first before we look into the system. So of course, we need a computer to be monitored and a monitoring station, right? This computer which is being monitored is connected to a port. It's called mirrored port. Your switch and your remote switch need to be connected. I'm showing the blue link here. But to utilize the reflector port, Ubiquiti requires you physically connect the 2 switches using another cable, connecting the reflector port with your remote switch. Immediate response will be this will introduce problem to your network because this will be a loop, right? Spanning tree protocol, the STP, will prevent this from happening. It will disable red one. Then you will not transmit any packets using your new physical connection, right? That's the biggest problem to understand this configuration. That's why in the demo, I'm going to use almost half of the time to look into the STP information to understand how the system even enable the 2 blue and red connections at the same time. If you want to know more about STP, please do check my separate video. I explain a lot of details about STP in UniFi world. In this video, I will not go to the STP details. I assume you understand what's discarding, what's designated, what's root. Just check the different port status. Of course, for the blue cable, this end is root, the other end is designated. No surprise. For the monitoring station, this part will have the manual forwarding STP state, because it's a probe part. It's not a regular Ethernet part. And when it comes to this computer to be monitored, this part is a simple designated part because it is a regular Ethernet part. The most confusing one, the red cable, this part will have the manual forwarding state. In the other end, in the remote switch side, strangely, it will have discarding state, but it doesn't prevent this part from receiving receiving the transmitted VLAN packets. To enable the RSPAN, you need to define a RSPAN VLAN. In your local switch, you set this RSPAN VLAN as the monitoring destination. In your remote switch, you set the same VLAN as your monitoring source. After you complete the settings in both switches, the system will have a successful RSPAN session. The RSPAN VLAN here is very crucial in this setting. Traffic for each RSPAN session is done using a user-defined RSPAN VLAN that is dedicated for that particular RSPAN session in both participating switches. That's the purpose of this VLAN. We will talk about how to configure it later. It's very straightforward. Just to configure RSPAN, it's very simple, but the STP part is a little bit confusing. Another problem is this type of configuration for UniFi switches only work in CLI fashion. It's not available in the UI, in network controller. They won't survive switch reboot. Because of the introduction of this red physical link, in this video I do not want to use my home network, so I will have these two switches working in a standalone mode, which means I won't adopt them to my home network, but I can still SSH into them to configure everything I need. Let's go to the system. In this video, I'm going to use this type of screen layout. The top right window is a remote session to the Wireshark computer, and the lower two windows are for SSH sessions into these two switches. Okay, I'm in. This new window you are seeing on screen is Mac machine, which we are going to monitor. Let me launch a terminal window, do a random internet activity. For example, let me ping 8.8.8.8. I will leave it there running forever and simply close the window. Now we are back to the Wireshark machine. Let me launch Wireshark. Choose the Ethernet port. It is capturing traffic already, but you don't see 8.8.8 because we haven't enabled the RSPAN yet. Let's go to the system to start our configuration. We will begin with the first switch, this USW Pro 24 switch. As we explained already, the way RSPAN works is you need to have a dedicated RSPAN VLAN for the red cable to transmit the traffic. Let me go to the left side SSH session, telnet to localhost, en for enable. Before changing anything, let's check the STP status for these red cables to connected parts. Let's start with the port on the first switch. Now just by looking into the diagram, you can already see a loop, but my two switches, they are still working. The network has not been broken, so the STP must be active. By the way, you may know, by default, UniFi switches come with STP enabled for each port. I expect the red one is disabled, otherwise there will be a network traffic loop. Let me make sure that's the case. Show spanning tree MST port detailed. Let's check the first port. Its route is forwarding exactly as we expected. Check the fifth one, so it's discarding. That's why this network is still working, because the red one currently is being disabled. Okay, so far so good. Let's also check the port 5 on the second switch. What's the STP status? So let me run the same command, throw spanning tree MST port detailed for the fifth port. That's forwarding because the other end is discarded. It doesn't matter what's this port status. As expected, before we change anything, everything works fine, even though we connected the two cables. Whether after we change something, when it comes to RSPAN, the system will automatically make the red one somehow work. Let's start with the VLAN configuration. I will run the command VLAN database, see what's the current VLAN configuration. Because this is a factory default reset switch, you only see the default VLAN here. Let me add some random VLAN. So let's say 100, 200. The next one is the most important one, 888. I'm going to use it as the RSPAN VLAN. we need to set the 888 as RSPAN VLAN. Go to config mode for VLAN 888. We simply say remote span. That's it. Now it is RSPAN VLAN. Next, we are going to configure the ports. Start with the first part. We are going to use this first part to connect to the blue physical connection so that these two switches can do the normal communication interface. The first part, tag VLAN 1, and then I say it will participate the normal VLAN, but not the RSPAN VLAN. Participation exclude 888. That's it. Exclude. We are good with the first part. Then we are going to configure the part 5. The part 5 is going to be the reflector part, and it will be wasted or sacrificed. So we are going to only use it to establish the second physical link to the other switch and use it as a dedicated reflector part for RSPAN communication purpose. Because we don't want it to transfer any other packets, let me configure the part 5, interface 05, VLAN tagging, of course, only 888. It should only participate 888. It should not participate 1, 100, and 200. We are done with these two connection parts configuration. It's time to configure the remote mirroring, or in CLI, it's called a monitor session. As explained in my previous video, you can configure totally 4 monitor sessions. So let me choose a random one. Let's say session 2. I will indicate source interface 22 in the diagram. For 22, it's the mirrored part. I already connected this Mac machine to the 24 part. So this will be the mirrored part. It will be the source interface for the monitor session. Then we need to indicate the destination. For the first switch, the destination is the remote VLAN we just configured, 888. But the system need to know which part is the reflector part. In our case, it's 5. We need to enable the monitor session 2, run monitor session 2 mode. Is enabled. If you want to make sure the monitor session is set up, you can simply show monitor session 2. Admin mode enabled. Mirrored part 22. It will mirror both receive and transmit. The reflector part is 5, and the destination RSPAN VLAN is 888. Perfect. It's done. For the first switch, if you check our Wireshark, nothing's changed. It doesn't capture anything because we haven't done the configuration in the second switch yet. Let's check what's the STP status for the part 1 and the part 5. Show spanning tree MST part detailed for first part. Yeah, it's forwarding and it's root. Nothing's changed as expected. Check part 5. See, it's automatically changing the state from discarding to manual forwarding. Why? Because we configured the monitor session. This is done behind the screen automatically by the system. This part is not disabled anymore. It is doing the manual forwarding. Let's move on to the second switch. I will speed up the process a little bit. I will simply type in the command and run it. Telnet localhost en for enable, add 3 VLAN. The exact same command. Exit. Configure the VLAN 888 as remote span VLAN. Configure the first part and the fifth part. Start with the interface 1. VLAN tagging 1. Participate include the 3 normal VLAN, but exclude 888, which is the RSPAN VLAN. Move on to the fifth interface. VLAN tagging the RSPAN VLAN, and the VLAN participation include the RSPAN VLAN. Exclude the 3 normal VLAN. We are done with the 2 parts configuration. They are exactly the same as the first switch. It's ready to configure the monitor session in the second switch. This time it will be different than the first one. Again, I can use a random session ID. Let me still use session ID 2. This time the source is remote VLAN 888. You don't specify a part because your source is a VLAN. The traffic is transmitted using this red cable. Destination is a physical interface, which is the 18 one. I already connected the Wireshark machine to the 18 part. We can enable the monitor session. See, right after I enable it, Wireshark start capturing the ping traffic 8888 and its reply, right? So the whole RSPAN session is already successfully established. Let me check this 3-part STP status. Start with the first part. I don't expect it to change at all. It should still be the designated status. Yeah, it's forwarding and it's designated. Check the 5th part. It's showing discarding now. Remember before starting the monitor session configuration, this part in the first switch is showing discarding. After we finish the configuration, this part becomes discarding. Even though it's in discarding state, it is still receiving the VLAN 888 traffic. My understanding is discarding just means it will not forward the packets out using the red cable to the other switch, but it doesn't prevent it from receiving the VLAN traffic through the red cable. That's why even though here it's showing discarding, the second switch can still receive the VLAN 888 packets. Move on to the port 18. It's manual forwarding because we configured it as a probe part. Let's see after we change the second switch whether the STP status for the first switch changed at all. Check the 5th switch in the left side SSH. It is still showing manual forwarding. It's not changed. Okay, so that's the final status after we enable RSPAN. Even though we still have 2 physical cables, they are both active and they have different purposes. Okay, thanks for watching.